Hello everyone, I want to start talking about solving our systems of linear equations using an algebraic approach. And there's going to be two methods we learn to solve these systems of equations algebraically. The first one I want to look at is called the substitution method. We'll run through the steps of the substitution method, then we'll use it to solve this example over here. The first step of the substitution method says we got to solve one of our equations in our system for one of our variables, either x or y, or whatever variables our equations are written in terms of. So once we've taken one of our equations and solved it for x or y, we plug that result into the other equation, the one we haven't used yet. That is the second step of this process. And after we've completed the second step of this process, where we actually make our substitution, that's where the name of the method comes from, by the way, we will then get a new equation, and the resulting new equation should have only one variable left in it, either x or y. We'll then solve for that remaining variable. Once we know the value of that variable, like x is equal to some number or y is equal to some other number, we can move on to step 4, where we take that known value for x or y, plug it into one of the original equations in our system, and then use that to solve for the remaining variable. If we knew x from step 3, then we'd solve for y. If we knew y from step 3, then we would solve for x. So let's go ahead and apply these steps for the substitution method to this system over here. Our first equation is negative 3x minus y is equal to 4. And our second equation is 3x plus 2y equals positive 4. So the first step says, take one of the equations in our system and solve it for one of our variables, either x or y. So I'm just going to go ahead and number the equations in our system as 1 and 2. And I think looking at the equations, it's going to be easier to solve equation 1 for y than it is to solve for x, or to solve for x or y in equation 2, just because, well, we can solve for y without having to mess with too much fractions. So we're taking equation 1 and we are going to solve for y. And so if we want to solve for y in equation 1, well, we really got to add y to each side and then subtract 4 from each side. So initially, if I do that step of adding y to each side, our equation will look like negative 3x equals y plus 4. But then to get y by itself, we have to subtract 4 from each side. That'll get us y by itself on one side. And then on the other side, we'll have negative 3x minus 4. So we've completed step 1. We solved our first equation for y in terms of x. Our first equation says y is always equal to negative 3x minus 4 when we're working with this system. So now we're ready to move on to step 2. We're going to plug the result from our first step into the unused equation. Well, we haven't used equation 2 yet. So now we're going to replace y in our second equation with the quantity negative 3x minus 4. So that first piece of our second equation is still 3x. But that second term, instead of involving a y, we know from our first equation in this new form that y is equivalent to negative 3x minus 4. So we simply just swap out or substitute y with negative 3x minus 4. And it's really important when we make these substitution steps, the quantity that we are swapping or substituting in has to be enclosed in a set of parentheses to make sure that we use things like the distributive property correctly. So remember, we're rewriting equation 2 with a substitution made. We have 3x plus 2 times y, and all of this is equal to 4. So we completed step 1 right here. We just completed step 2 down here, and now we're ready to work with step 3. Because if we look at the equation we just wrote down in step 2, the variable of y has been eliminated, and now only x's are showing up, and that means we can solve for x and find the value of x that must satisfy our system. So how are we going to solve for x here? I think the way I would do it would be by expanding and combining like terms. So if we want to expand or distribute that factor of 2 throughout our quantity in parentheses, we're going to get 2 times negative 3x. That'll give us a term of negative 6x. We have to also remember to distribute that factor of 2 to the constant term of negative 4 in our parentheses. 2 times negative 4 will give us negative 8. And then we can't forget that all of this is equal to the same right-hand side of positive 4. Okay, we haven't solved for x yet, but we're one step closer to doing so. Now we can combine like terms. 3x minus 6x gives us negative 3x. And then also we want to move that constant term of -8 over to the other side of our equation. So we can kind of just add 8 to each side as well to do that. And let's see, 4 plus 8 will be the new right-hand side of our equation, and that is positive 12. So negative 3x equals 12 is a lot easier to work with and solve. We just divide both sides by 3, and we see that x is equal to 12 over negative 3, which we want to reduce and simplify down to negative 4. So now we have completed the third step in our substitution method. We solved the resulting equation that we got after making our substitution and eliminating the variable of y. We found that x is equal to negative 4, and so now we're ready to finish this off. All right, and so now we're ready to move on to step 4 in our process. We know our x value is negative 4 for the solution to our system of linear equations here. Now we just have to plug that x value of negative 4 into one of our original equations, and technically we don't even have to use one of our original equations. We could also use that modified version of our first equation, which is really nice because it tells us exactly what y is equal to in terms of x, and we're trying to find y at this point. So that modified version of our first equation tells us y is equal to negative 3 times our x value, which we now know is negative 4. From negative 3 times our x value, we have to subtract 4 away. Let's see what that gives us. The product of negative 3 and negative 4 is positive 12. And if we subtract 4 away from positive 12, we get positive 8. And so now we know the entire solution to the system of linear equations. We have one solution. It's going to be that point of intersection between our two lines. The x-coordinate is negative 4, and our y-coordinate is positive 8. And so the solution to the system, negative 3x minus y equals 4, and 3x plus 2y equals 4, is going to be the point x comma y, where x is equal to negative 4, and y is equal to positive 8. All right, let's go ahead and run through another example of solving a system of linear equations using our substitution method. This time the system we're looking at has a first equation of x plus 4y equals 3, and a second equation of x plus 6y equals 2. So let's go ahead and label our equations 1 and 2, like I like to do. And so the first step of the substitution method is having to solve one of our two equations for one of our variables. And it looks like x is going to be pretty easy to solve for in either of our equations, and it doesn't matter which one we work with or use. So let's go ahead and solve for x in our first equation. This is going to be the first step of our substitution method. I'm going to go ahead and label that first step in green. And what we're doing is we're solving equation 1 for x. And we can do that in one step just by subtracting 4y from each side. And that tells us that equation 1 equivalently says x is equal to negative 4y plus 3, or we could write it as 3 minus 4y. That doesn't really matter. Okay, so we have successfully solved one of our equations for one of our variables. Now we're ready to move on to step 2, which is the substitution step in our substitution method. We use the first equation to solve for x, and so that means we're going to use the second equation in our substitution. So now we need to replace the x in our second equation with negative 4y plus 3. All right, so now if we replace x in our second equation with negative 4y plus 3, we can rewrite our second equation as negative 4y plus 3, that's this x here, plus 6y is equal to 2. And now notice there are no longer any x's involved in that equation, just y's, and we can now solve for y. And that'll be the third step in our process, is solving this rewritten second equation for y. So let's combine like terms. Negative 4y plus 6y gives us a positive 2y. So the left-hand side of our equation can be simplified as 2y plus 3 is equal to 2. We can then subtract 3 from each side. You can get 2y is equal to negative 1. We can divide both sides by 2 and find that y must be equal to negative 1/2. And so that completes step 3. We took that resulting equation and we solved it for the remaining variable of y, and we found that y must be equal to negative 1/2. So now we're ready to move on to the final step of the substitution method, what we're calling step 4, and that's where we back substitute. We know y is equal to negative 1/2. Now let's go and use that to find x. Well, in our earlier work, we saw that x was equal to negative 4 times our y value plus 3. So x is equal to negative 4 times our y value that we found just a second ago to be negative 1/2. If we add 3 to that, we'll get our x value. Well, negative 4 times negative 1/2 is going to be positive 2. So this simplifies to 2 plus 3, which is equal to 5. And so now we have both our x coordinate and our y coordinate for the solution to our system of linear equations. So let's go ahead and write our final answer down as a nice ordered pair, x comma y. So x is 5, y is negative 1/2. That is the point of intersection or the solution to this linear system.